Hello everyone, welcome to Mina's Tech YouTube channel. In this video, we will learn easiest way to understand microservice architecture. So let's begin this video. Before understanding microservice architecture in a simple way, let's check out the monolithic architecture for a while. I hope you remember. Let's say we have a client who is sending a request to business, and business interacts with the database or data interfaces and gets the response back to the client. Monolithic architecture is a software design approach where all components of an application are integrated into a single unit. In this architecture, the entire application includes the user interface, business logic, and data access layers. It is developed and deployed and maintained in a single entity. Monolithic architecture is simplicity. It is straightforward development and deployment process. Cost effectiveness, less infrastructure, overhead, and simpler to deploy setup compared to distributed systems. Performance-wise, it is better. It can be provided better performance due to reducing communication overhead between components, as everything is running in a single unit or a single same process. Monolithic is easy and simple, but there are few cons too. Scalability issue. It's really difficult to adopt new technologies, and it is risk of downtime. So, to overcome all these and to make more scalable, we have microservices. Let's say a client is hitting a request via HTTP protocol using REST API to multiple microservices using @request mappings, and those microservices are connected to their respective databases. Now response is sent back from microservice as JSON and to front end. If we have hundreds of microservices communicating to each other, it's very difficult to route the request and response. So to make this easy routing, transformation, and secure API gateway are integrated. Now the request is sent from client to API gateway via REST calls, and this will redirect the request to respective microservices. Now we have integrated API gateway and multiple microservices. Each microservices works with different port numbers. And what if we have hundreds of microservices? Now there should be a service where we can track all port numbers and service names. So let's integrate with service registry using Eureka Cloud Servers and configure every microservice with Eureka client. Eureka server default port number is 8761. So once we run all applications, check localhost 8761, we should see all running instance of microservices with port number and service names. Okay, we have integrated with microservices, API gateways, and service registry. What's next? Now we need to check if all microservices are working state or down. For example, if microservice 1 depends on microservice 2 result and microservice 2 is down, we have to tell client, or we need to send a response saying it is taking more time than expected. Please try again later. So for this, we design fault tolerance, which we call as circuit breakers. When any microservice is down and unable to fetch the response, then we should configure and write a fallback method so that we can give a response to the client. So here we learned integrating API gateway, communication between multiple microservices, service registry, and fault tolerance, which is circuit breaker. During creation of microservices and integrating with different services, we write a lot of configurations like data source details for database, Eureka client details, and many more. So these can be duplicated in each and every microservices. We write all our configurations in application.yaml file or application.property files. So let's create a cloud service called cloud config server, which will connect to Git and commit the common configuration in application.property file or YAML file. This will help to avoid duplicate configurations. So now we are ready with API gateway, microservices, service registry, fault tolerance, cloud config servers. What if we have a consumer service which wants some details from us in streaming way, like giving updates, running details continuously? We can connect through Kafka or Camel to transfer the results in messaging format. For best practice, we should follow logs in each service so that we can track logs in success or failure cases. So let's integrate with distributed tracing and logging service. We have multiple third-party tools like Splunk and Stack where we can track all our logs of microservices. So that's it. This is microservice architecture. I hope you got so much information on microservice architecture. We will create an application and implement it. So please subscribe to our channel for more videos. Thank you.